What if I told you you can measure up to 100 volts safely using just a few components and even feed it directly into your microcontroller ADC without blowing it up? Let me show you how I build a simple but powerful module. Let's start. So I just open my schematic designing. So in this project I design a compact PCB module that can measure high voltage up to 100 volt and convert into a safe readable signal for any microcontroller like STM32, Arduino or ESP32. So this is the module I built. It is has a screw terminal, okay, for the input voltage and conditional circuit and a output header that connects directly for your ADC pin. So here is the magic of voltage divider rule. So the first problem is simple microcontroller cannot handle high voltage, so I use a voltage divider circuits using of two resistance, that is R1 is 330 kilo ohm and R2 is 10 kilo ohm. This is scale down the input voltage. If I apply 100 volt at the input, the output becomes around 3 volt, which is safe for 3.3 ADC. Okay, and voltage is equal to the V in by R2 upon R1 plus R2, that is the voltage divider rule. And next I added an RC low pass filter using a 1 kilo ohm and 0.1 microfarad that helps remove noise and giving a stable voltage signals for the ADC. This is very important when measuring the real world signals where noise can affect accuracy. So finally the filter signal goes to the output connector, which you can directly connect to the microcontroller ADC pin. So I just show you the PCB file. Okay, I just tap on that. Okay, so this is my PCB file. Since we are dealing with the high voltage, always be careful use a proper isolation and never touch the circuit when powered. Why this design in good? Okay, so just I show you a 3D modeling. Because of it is measuring the battery monitoring, power supply measurement, industrial sensing, smart energy projects. If you want a PCB file or code for this project, let me know in the comments. And if you like practical hardware design, like it, subscribe. I post real engineering project, not just the theory. And next time I will show you how to calibrate this for the accuracy voltage measurement, so don't miss that.